It's once again equations in one variable. But it's not going to be linear. We're going into the wonderful topic that you've had many, many times before, quadratics. Okay? Now, in Algebra 1, you probably covered quadratics in like maybe a unit or two. I remember in my Algebra 2, we took probably 2 months to cover quadratics. In that was Algebra 1. In Algebra 2, you did it in maybe, I don't know, a month maybe, 3 weeks. Today we're going to do it in 1 day. Okay? Everything you need to know about quadratics. Now we're not going to do graphing, just solving the equations. So, first of all, someone tell me, what is a quadratic?
X
Definition.
Squared.
It's what?
X squared. X.
Excuse me.
I didn't hear you. Say it one more time.
X squared.
Okay, so it has an x squared. That means it's second degree. It's a second degree polynomial. So something like f of x equals x squared, we know when we graph it, we have what type of graph?
A parabola.
We have a parabola. And you can tell me a couple characteristics of a parabola. Just give me a couple.
Symmetrical.
I'm in class, people are staring at me right now. What's that? He'll want 2x. Yep. All right. Nope. Bye. Okay, so now that that's gone off and I'm a terrible, terrible teacher, a couple years ago, if your phone went off in class, we confiscated phones. So I keep up that tradition. Who's going to hold my phone for the rest of the hour?
Oh, me.
No. All right. So my phone is now confiscated. It's turned off. I do apologize. If you'd like to keep it the rest of the day, the answer is no.
I wouldn't do that.
Don't go through my phone.
No, she put it up. I put it up.
It's locked, so we're good. Okay, so we have a parabola. So what did we say? What's the characteristic of a parabola?
It's curvy.
It's curved.
Yep.
What'd you say?
Symmetrical.
It's symmetrical.
Come on, Brad.
What else?
Just look.
Like it has like usually it's infinite on both sides and it like goes back up.
Okay, when you say infinite on both sides, what's that referring to? Domain.
Right.
So the important thing is the domain goes infinitely in both directions, up, down, left, and right. So its domain is all reals, and its range is also all reals. No, that's not true.
That's not true.
Why is its range not all reals?
Because it has a bottom.
Ah,
Ah.
so it does go up forever, but it does have a,
Bottom.
what do we call that?
Midpoint?
Midpoint, minimum point, maximum point. We call it the vertex, right? So the vertex limits the range to like 2 to infinity or negative infinity to 5, something like that.
So
it's
what do
gonna
you
have some
put for
sort of limited
range?
range. What's that?
What do you put for range then?
Well, it depends on if it's going up or down.
What was that?
Because you either have a min or a max, so the range we don't really know. Okay. Okay, so we have the domain is all reals, we have the range is limited, we have it symmetrical, we have it's a parabola, it's U-shaped. What else? Anything else major? Oh, we said it's symmetrical, right?
Yeah.
So what's that called?
Axis of
Oh,
symmetry.
Axis of symmetry. Very, very good. Okay, so let's look at the different forms of the equation. So now we're going to look at the equation itself. If you want Roman numeral 1, standard form. Okay, so standard form looks like ax squared plus bx plus c equals 0. And if we're trying to solve from standard form, if you go back to lecture number 4, we did this with factoring, right? You remember factoring back in lecture number 4?
Yeah.
Okay, so if I give you something like, let's say, just to review from lecture 4, x squared minus 5x plus 6 equals 0. How did I factor that?
X minus
What
2x.
X?
minus 3.
Okay, so, it's back here, you were kind of trying to explain it to me, what'd you say? Yes.
What adds to 5 multiplies to 6?
Okay, very good. So we want to know the factors of 6, and then has to add to equal -5. So we have, we know we're going to have x minus, and then of course 3 and 2 multiplied equals 6, and add equal -5. Okay, so then what do I do from there? I reviewed this in lecture 15. How do I solve it from there? It's called the ZPT, lecture 15. I'll give you a hint, the T is theorem.
Zero product, 0.
Outstanding from the right side of the classroom, zero product theorem. Okay, which means if I have a product that's 0, what that tells me is one of the two factors has to be 0. So then I know that either x minus 3 equals 0 or x minus 2 equals 0. And then you solve these two equations and you get your solutions.
So are they both true, or is one of the two of them true?
They're both true. In this case, they're both true, yes. Now, what did we just find? We found the solution, but if I go back to the graph of the parabola, what is 2 and 3? What points?
3.
Say it again.
3.
Good guess, but no.
The vertex?
The what?
Max?
Vertex?
Good guess, but no.
The minimum or maximum?
That'd be the vertex. Good guess, but
whoops.
no. Because a quadratic can't have 2 vertices. It can only have 1 vertice. But it can have 2 what? What'd you say?
X-intercepts?
X-intercepts. Exactly right.
Oh, you had
So
it.
that means it crosses at x equals 2, and it crosses at x equals 3. So those are my x-intercepts. My solutions are the x-intercepts. And if you don't remember this from Algebra 2, or your algebra teacher didn't teach you, the vertice is going to be halfway between 2 and 3. So the vertice is going to be at 2.5. And then whatever, that's going to be your axis of symmetry. It's going to be halfway between those two x-intercepts.
Okay.
Say it again.
I'm saying okay.
Did you know that?
No, I thought you
I mean, it makes sense.
I mean, I don't know.
No, no one taught me.
It's terrible. Your algebra 2 teacher was horrible.
Oh, okay.
Example number 2.
Was it him? Yep.
Let's do this one. X squared minus, oh, I forgot already. Minus 6x plus 9. Solve it. 6x plus 9 equals 0. Don't say it out loud, just do it on paper. Ava, do you have this one factored?
Uh-huh.
What'd you get?
X minus 3. Wait.
What's the other one?
It's also X minus 3.
It is.
Okay, I was second guessing myself.
And we have a perfect square trinomial with x minus 3 squared. Okay, so then we only have one answer, x minus 3 equals 0, so x is going to equal 3, which means if I graph it, how many x-intercepts do I have?
1.
So it actually rests on the x-axis.
Okay, so that's what that means.
Yeah, it's just
Okay.
resting on the axis. The vertice is on the axis. That's what a perfect square trinomial does. Okay. All right. And then, of course, from lecture 4, the last one, I was going to have a special guest, but my special guest couldn't make it to go over this one, so I had to do it. So we have 6x squared minus 7x minus 5 equals 0. How did I factor this one? What do we do?
Bottom
We did bottoms up. Remember bottoms up?
Yeah.
It's not.
Which is why I was going to have a guest speaker come in and do it. So in bottoms up, what's the first step we're going to do?
Multiply them.
Multiply what?
AC.
A and C. Take 6 times 5. So I end up with x squared minus 7x minus 30 equals 0. Okay? Then what do I do?
That's the answer.
Then you factor, right?
Factor.
Then we factor as normal. So x and x multiplied equal negative 30, add to equal negative 7.
Negative 10 and 3.
Negative 10, positive 3. And that is not my final answer. What do I have to do with bottoms up?
The 6.
At what?
Divide by
The
s-
6.
The 6 has to come back in, right? So since I multiply by 6, I have to divide here by 6. So let's see, I get x minus, this reduces, what does 10 over 6 reduce to?
5 over 3.
Go away.
So 1/3.
Go away. So 5 over 3.
Oh, I thought I got it wrong and that's why you didn't write it down. I was like, wait, what?
No, it was messed up. And what does 3 over 6 reduce to?
1 over 2.
1 over 2. And then this is where the bottoms up phrase comes in, right? Because these are fractions, we can't have, this is actually a good answer, but I have to go ahead and do the bottoms up. So the bottom comes up and I'm left with 3x minus 5, and I'm left with 2x plus 1.
Why does this work? Like, how
Did
does
we
it
still
make any
solve that out, or is
Say it
that?
again?
Corbina calls it math magic.
You
She
just said,
never
why
told
does it
us how
work?
works.
Okay, so here's my little thing. Later on in this class period, hopefully this class period is not today, tomorrow, we're gonna walk through a mathematical proof, a derivation. So it's not like math magic. For the longest time, I'd say probably 6 years ago, this was just magic. I just like, it always worked, why does it work? So I actually looked it up, there is a proof for it. Okay, if you're interested, you just Google proof for bottoms up. There's a proof as to why it works.
How
Okay.
long is the
I don't remember. I looked it up and I followed through it and I'm like, that's kind of cool, but I still don't like the method. Okay, now, here's the thing, if I'm solving, if I want factors, these are the factors, right?
Yeah.
But if I want to solve, let's just leave it right here. Let's just take x minus 5/3 equals 0. So x is gonna be 5 over 3. Add 5/3 to both sides. And then you have x plus 1/2 equals 0. So x equals negative 1/2, subtract it from both sides. Because that's what you're gonna get when you solve these two. So if you're solving, don't do the bottom up part, just set them equal to 0.
Is Delta Math going to specifically like say, like some of them are for solving, some of them are just to leave it?
I think they want you to solve all of them.
Okay,
I think Delta Math is, one of the questions I put, I think are all solving.
so we'll
Because that's
just
the
use
point
the
of this.
fractions.
Say it again?
So we'll just use the fractions.
So you just use it.
Oh, okay, that's easy enough.
Okay. I've gone through that very quickly with factoring. That's lecture 4 if you need to go back and review it. Now, what about,
Wait, Mr. Phillips,
oh,
I have a question.
oh,
How would you,
hold on.
how do you graph that thing?
How did you graph that?
Yeah.
Okay, so you have your x-intercepts. Let's see, 1, 2, 3, 1, 2, 3. I know it goes up, right? Okay, so 5/3 is like 2 1/3. So about right here. And I know negative 1/2 is about right here. Okay, so then your graph would look something like that. If you want to get more particular, you can find out what's exactly halfway between it, and that's going to be your vertex. But that'd be a good enough sketch for me, because you've got your x-intercepts, then it goes up.
I never realized how, like, I didn't realize your pen had like two sides where you could draw the two different colors.
Yeah, you can tell which side.
That's so interesting.
Yeah. I didn't know that till about a month ago when Logan Dries showed me. Okay, so what if it's not factorable? Roman numeral 2. What about quadratics that are not factorable? Now, what do we call a term that has no factors? What do we call a number that has no factors? It's just prime, which is one in itself. So it's just prime. These are prime polynomials, prime quadratics. Okay? So what do I do with those? I have to have a method to solve them, correct?
Yes.
Okay? Did you say you guess?
Yeah.
Well, the way you said that is very suspicious. I've gotta have a way to solve
You
it.
gotta have a way to solve it. So we introduced to you, and I'm not gonna sing it, you can sing it if you like, but the quadratic formula.
Give us something to
Does anybody wanna sing it out loud for us?
Oh,
Sing it.
I think I remember it.
What
The
does it
top
sound
goes
like?
the weasel.
What does it
How
sound
does it go
like?
again?
X equals negative B.
Oh.
I don't remember it.
Oh.
I've never learned that.
All over to
All over.
There you
I know
go.
that
That's all
for
I
you.
got.
I know that for you.
Okay, now, with the quadratic formula, there is a specific part, and this is gonna be a test question, I believe we did this before, earlier in the year as well. We have a special name for, let's go over here to the side. We have a special name for b squared minus 4ac. What do we call that? We had this back around lecture 4 again. What did we call b squared minus 4ac? There's a special name for that. Starts with a D.
Derivatives.
That's calculus.
Denominator.
It's not the denominator.
I'm seeing nothing.
Discriminatory.
Discriminant.
Yeah,
I would not have guessed that.
Yeah, I never would have thought that. Never would have
Never
came
heard
up with that.
Okay, so the discriminant, so what does the discriminant do? The discriminant is gonna tell us what type of answer we're going to end up with. There are three possibilities. When it comes to quadratics, you're gonna have one of three solutions, okay? If b squared minus 4ac is positive, which means it is greater than 0, okay? So like 14, 37, 123. Anything that's positive, notice it doesn't have to be an integer. Okay, it can be anything. But if that b squared minus, b squared minus 4ac is greater than 0, it's positive, you're going to have two real solutions. Okay? If your radical, underneath this radical, is a positive number, you're going to have two real solutions. Okay. Another option for b squared minus 4ac is it's going to be negative. It's going to be less than 0. Okay? You're going to have two. Lots of ways to mark this one. The correct one is called complex. Or what's the letter we typically use with complex numbers? They're both going to have an I in it. You're going to have an I. Okay? So you're going to have a negative radical. Okay?
Will you accept either?
Lame.
Yeah, I'll accept either. But in your answer, you have to have an I.
Oh,
Your answer
okay.
with an I. What's the third option? Either you're greater than 0,
Equal to.
less than 0, last one is equal to 0. So it's equal to 0. This one's positive, negative, or it could be 0. That's honestly the best one because you have one real number. And typically, if you end up with 0, the problem is more than likely factorable. More than likely. Okay? Now, real quickly, I'm going to jot in here, and I should have left more room, so I apologize. But I want you to also know what the graph would look like in those three cases. Okay? So if there's two real, your graph is going to look something like that. You're going to have two x-intercepts, just like our first example. Okay?
Okay.
So if two real, you're going to have two x-intercepts. Okay? And once again, it could be facing up or down, but it's going to have two answers. Okay? What would this one look like? Two complex. What do you think that would look like?
The other way.
No, it could be up or down.
Yes.
Is it just going to not have any x-intercepts?
No x-intercepts. There's no real answers, so it's either all above or it's all below the x-axis. It never crosses the x-axis.
Like all in
What if it
one
crosses the
section?
line? Is that
That's
fine?
perfectly fine. I don't care. You can cross the y-axis anytime you want. It will have no x-intercepts. What'd you say?
I said it had to stay in like one section.
One half. Has to stay on the top or the bottom. And then, of course, if there's 0,
Bless
Thank
you.
you.
what's that going to look like?
Why would it just be on the origin?
Say again.
Why would it just be on the origin?
Change origin. It's going to be on the
The x-axis.
x-axis.
Okay.
Like resting on it.
It's
Like
going to be resting on the x-axis just like that. And you've got one x-intercept. Okay?
Oh, okay.
That's what the three graphs will look like compared to, so your discriminant, you can look at your discriminant, just that b squared minus 4ac, and say, you know what, I have two real answers, I can solve. Or, you know what, it's complex, it's not gonna help me, it's no answers. Okay, or depending on what the application is. Okay?
Is there ever a point in math where you have to figure out what the complex numbers are?
Yes, and we're gonna do that.
Oh, okay.
It's just, there may not always be an application for that. Okay? So let's do an example. Hopefully you have that chart down. I do believe this is the quiz and test I actually asked for this. I don't think we've done that yet. I actually asked for this chart, and you have to fill, I put it partially, then you gotta fill it in. Okay, if it's positive, greater than 0, it's 2 reals, negative, less than 0, 2 complex, 0 equals 0, 1, answer. Okay, so let's go with some examples.
Wait, what's the difference?
Yes,
What's the complex number again?
I'm sorry?
What's the complex number?
It has an I in it. So like 4 plus 3i,
So, is
Or
it
just-
imaginary number?
7i. I'm sorry?
Is that imaginary number?
So the imaginary is the I. This set of numbers is called complex. So it has a real part and an imaginary part. When it has both, they're always considered complex. All right, so an example. Let's go with an example. Let's use one out of the book. 3x squared plus 5x plus 1, I do believe, equals 0. Now we could probably try and factor this one. I'll be honest, if I'm solving these, I look at it very quickly and I say, okay, x squared plus 5x plus 3, because I multiplied a times c. What multiplies me to 3 and adds to equal 5?
No.
And if I don't have it by now, I don't even continue to try. I'm done. In this case, there is none. Okay, so we're just going to get rid of that, and we're going to go ahead and use the quadratic formula. Now, some people do it in steps, some people do it different ways. I always do it in 2 steps. Number 1, I always find b squared minus 4ac first. Okay? So let's go back to our problem. What is a?
3x squared.
3 is always the quadratic term. This is the quadratic term. It's the one in front of the x squared. It's not the one that comes first, because I could easily write this as 5x plus 1 plus 3x squared. It doesn't change a, b, and c. A is still the quadratic, the one in front of the x squared. Okay? B is always the linear. And which one's the b?
5.
5, because it's whatever's in front of the x, right? Okay? And then c is always the constant. It's always the one that's by itself. Okay? So in this case, it's going to be 1. I have had kids think about, well, it's whatever, no, doesn't matter what order it's in. Quadratic, linear, constant term. Okay? So then we plug it in. So we have b squared minus 4 times a times c, and we multiply it out. So 25 minus 12. So what type of answer am I going to have? I end up with 25 minus 12 is 13. My discriminant is greater than 0, it's positive. So how many, what type of answer will I have?
So,
Maybe what?
so it's positive because it's 13 is greater than 0, right?
Correct. 13 is greater than 0, it's positive. Therefore, I'm going to have what type of answer?
2 real.
I have 2 real.
Oh, okay, that's what you're asking.
I'll have 2
I
real.
was just confused with what you're asking. My bad.
I'll have 2 real answers. Okay? Which means I'm going to have 2 x-intercepts.
Yeah.
Make that connection. Okay? All right, so the number 2 is when I actually use the quadratic formula. X equals, so b is 5, so a negative 5, plus or minus the square root. And now I've already solved for the radical. I already know what goes underneath there. Okay? I've already solved b squared minus 4ac, so it's 13 all over 2 times 3. So negative 5 plus or minus the square root of 13 over 6. Okay, now, on Desmos. Desmos will not give you this as an answer. Okay? Desmos likes to split it up. So this is going to make it negative 5 over 6 plus the square root of 13 over 6.
Well, I think it plus or minus.
Huh. And then it's going to give you negative 5 over 6 minus the square root of 13 over 6.
That's overly complicated for no reason.
Now, first of all, they split it up. They put the 6 under each one of them is right as 2 separate fractions. Second of all, I guess apparently when they programmed it, they didn't put in a plus minus symbol. Although they have it as one of your choices when you click your answer. I don't know why that does that, but a lot of times they'll leave that as your answer. So don't freak out, those mean the same thing. It's just written out individually.
I gotta go.
So that's just the final answer?
Say it again?
So
That's the final answer. Yep.
So how do you get that?
Oh, I'm sorry, is class over? Did we go to choir?
My ears
I
are
could
bleeding.
have sworn I was still in math class. Let's see. 11:20. Oh, yeah, we're still in math class. Bunch of choir people. Any questions on this? Are we good?
I'm in choir.
You're in
My
choir?
bad.
Right now? You're not in choir.
I might be.
Are you guys going to wherever this week?
Yeah.
You are, okay.
On the quiz, if there's a question like that, would you require us to graph it?
This chapter is going to be all about solving, so probably not. So your question was, how do I graph this?
Basically, just in case, but if you're not gonna ask, then no.
Well, there's lots of ways to graph this. We can go through like, find the vertex, whatever. If you plug this into your calculator, you'll get 2 decimals. There's your x-intercepts. Sketch it. But I don't think I'm going to do that. All right, so let's do another example with a different type of answer. Okay. This was going to give us x squared minus 4x plus 8. And this is one that's going to deal with that old, terrible imaginary number I. All right, so let's go ahead and solve. Can I factor this? Anything multiplied equal 8 that adds to equal -4?
No.
No.
What, 6 and 2?
Oh.
Well,
What's
yeah.
that times?
Yeah.
But it doesn't
two?
multiply.
Oh, yeah, it's
So
12.
just,
It's equal to-
So close yet so far.
So close. All right. So what's A? And please do not be that one student, Layla. Yeah, thank you. Please don't be that one student who does this, that A equals 1x squared. Don't be that one student who does that. Okay, it's not 1x squared. What's A? Just 1. Okay? Every year I have 1 or 2 students insist on putting the x with it. You don't put the x, just the number in front. Okay, what's the B? 4. What's C? I will tell you this on a quiz or test. If you screw up and make a computation error, you at least get a point for this.
okay, period.
So just identifying them, you get at least +1 point.
Okay, so
Okay.
you want us to write that
I
down.
do. I want you to write that down. Number 1 gives us b squared minus 4ac. You get a point for writing the equation out. So we would have -4 squared minus 4 times 1 times 8. So if you put in your calculator wrong and you get some computation error, at least you get a point for writing it out correctly. Okay, then I know, okay, it's just a computation error.
So we're already getting like a third of the points just for like trying.
By plugging in by identifying the points correctly, not by writing x squared, just by writing the numbers and then plugging it in correctly.
Okay.
You get about a third. So let's see, -4 squared is going to be 16 minus 32. I get -16. Okay. So because my discriminant is -16, what does that tell me about my final answer? It's going to be what?
It's gonna be
Two
a
complex.
complex.
2 complex, or 2 with i's in it. Okay.
Would you take either one or do you have to say I?
I would always put complex.
Okay.
I just want you to remember complex means it's going to have an I in there.
Question.
Yes.
So why don't we just combine like terms on the left side of the like equal sign? Like 16 minus 32. Like I know that means -16, but like, so I don't know, maybe I'm just being silly. Like what's the point of leaving it so just saying -16 equals -16? Because that's just the,
That's the answer. I evaluated it equals -16.
okay.
And that's what I'm going to put into my formula. So number 2, I have x equals -4. Be careful. Okay, negative. Plus or minus the square root of, here's my -16 goes, all over 2a. So let's clean that up a little bit. What's a negative and a negative?
Positive.
Positive.
4 plus or minus, okay. What is the square root of -16?
4.
Close.
4i.
4i. Because the negative is I, square root of 16 is 4, so 4i all over 2. if you need to see that, we have the square root of negative 16. I think we go back to lecture 5, we talked about these. The square root of negative 1, the square root of 16. This is going to be 4. This is going to be I.
Oh, 'cause,
So I get 4.
okay.
So just say you
Because the
get
negative one is a, okay, okay.
Lecture 5 if you need to review that. Yes.
So your 4i, did you just do the square root of negative 16 to add an I to the end?
Yes. That's really what I do. When there's a negative, it's going to be an I. Simplify the rest. Okay, now, last minute before the bell rings. What does 4, 4i, and 2, all three of them have in common?
2.
All of it 2.
Yeah.
So you have to go 2, 2, so you're left with 2 plus 2i.
Oh, wow.
And there's your answer. You'll plug it to.
Isn't it plus or minus 2?
Plus or minus. Sorry.
Good catch, Lucas.
Thank you for paying attention. I obviously wasn't.
Will we lose a point if we forget to write plus or minus?
Yes.
Okay.
Or if you were doing on delta math, it'd be 2 plus 2i and 2 minus 2i. Okay? All right, so stay with me. Stay with me for 30 seconds. Less than that. So tomorrow when we come into class, we'll pick right up here. We're going to do a procedure called complete the square. And we're going to prove, we're going to show you where this comes from. I'm going to show you where that comes from tomorrow in class. Have a fantastic Monday. Hopefully the Bears can actually win
Do we
tonight.
not still have 10 minutes?
Say again.
Yeah, we're good.
Are we here till 10:30?
No.
We have like 10
Dang.
minutes. Why are you getting up?
Oh, bro. I'm not. Hey,